Hello, Amrit sir. Amrit sir.
Yes.
Yes, sir. So, sir, we are starting the session. I would invite Dr. Mrs. Praveen Saxena, ma'am, for their welcome remarks. Over to you, ma'am.
Yes, thank you, Rohit. So, good afternoon once again. A very warm welcome to all of you. We've been having a host of series of webinars in this Azadi ka Amrit Mahotsav. And initially we had thought 75 numbers is a huge number, but now I feel seeing the number of topics, while we have covered 27, 75 is a small number because every day we come across new sectors, new topics, and we would really like to deliberate on each and every one in this series. Air quality is something which is very important. We have to maintain a healthy environment. We have to maintain a healthy, healthy emissions, we should say. Our goal also in the Panchatantra is that we have to reduce emissions, so we have an healthy environment. In fact, I was reading the reduction in emissions is not only good for the environment, it is also has accrued social benefits in terms of better environment, in terms of reduction in premature deaths. IAP, indoor air pollution, is one of the main contributors of pollution. And here we have a number of premature deaths. So this also can be reduced if we go and control the emissions. Now, how do we control our emissions? How do we go over to a better environment? This is one area which needs a lot of deliberations. And here, the transition to cleaner fuels, better fuels, which have reduced emissions or no emissions, are our goal. Now, biomass is such one area where we have alternatives such as pellets, briquettes. We can use biomass as a liquid for fuel. We can use as a solid for fuel, and even a gas form can be used for fuel. And we have a lot of programs going on it. In fact, pellets has been even the Air Commission for Quality Management, Air Quality Management has recommended that the industries, they should switch over to biomass fuels or to cleaner fuels all over in NCR latest by September 2022. Otherwise, they will face closure. So this is the type of regulation which is coming and which is really the need of the hour. We have to, we have to shift. We have to move towards cleaner fuels. Skill Council also has a lot of focus on, promoting alternate fuels like biomass. We have studied the supply chains, the rural waste supply chain, the urban waste we have studied, and we have come up with job rules which will not only improve, have an implication for the air quality of the environment, but also the entire supply chain to be managed in a way that we can provide a consistent supply of feedstock for our biomass alternatives. Now, we also did some, evaluation of the air quality job roles for iForest, and it is a study by World Bank, and there 70 job roles across all sectors have been identified, and we are working on them. So I would say that biomass fuels, biomass pellets, biomass in any form is something which is very desirable, and we need to take it forward. So today we are very fortunate to have with us Mr. Amrit Khater. He is an ardent supporter of promoting biomass fuels. In fact, pellets. In fact, I know him for the last 2 decades since I was in MNRE and Delhi government. And we did a lot of work in trying to move forward for classifying pellets as green fuel. So I welcome you, Mr. Khater. And I can say that you are a technology-driven person, very much in sync with the latest upgraded versions of the machines used for this biomass pellet producing industry. Mr. Khater has a master's degree in sustainable development, and he has completed his MBA specializing in family business and entrepreneurship from IIM Bangalore, which is a very reputed institute of India. He is the 2nd generation in the business and is specialized in giving solutions to biomass industries to overcome complex problems. He has a long experience in biomass, in briquettes machines, pellet machines, dryers, hammer mills, air density separators, convey and conventioning systems for biomass, municipal solid waste, and other industrial use. So you see his specialization is across the spectrum in all the equipment, all the machinery which relates to biomass pellet production. These solutions, as he has told us, have all been developed in-house. He has a sound knowledge of handling municipal solid waste and biomass and converting them into renewable energy pellets and briquettes. We have had many interactions with Mr. Khater, and we found him to be very knowledgeable across the sector. He has really played a great role, right from setting up of the manufacturing equipment, in fact, developing the manufacturing equipment and setting it up and producing the biomass pellets. I forgot to mention that even the power generating industries, there's a mandate for them to use, they can use up to 5% biomass pellets. And Mr. Khatter also is one of the main suppliers for these power generating units. So I could say his in-house R&D, he has with his in-house R&D, he has developed a lot of equipment, lot of this thing, and he is geared to take up turnkey projects, both India and abroad. So he is again one more line of appreciation. He has developed fully integrated and automated fuel processing system in the briquette industry. So with so much laurels to your credit, Mr. Khatter, I welcome you to this, and we would love to hear you and gain more from your knowledge and expertise. Welcome, and over to you, Mr. Khatter. Thank you very much.
Very good morning, Dr. Dhamija, and all our guests here. So we are here today to basically discuss on the production and use of biomass pellets as green fuel. And as most of the people here would now be aware that biomass pellets and briquettes have been finally awarded the status of green fuel, renewable fuel, clean fuel, and is considered as the approved fuel across almost across all states now. So, and this is a very, very upcoming industry. So, Dhamija ma'am, I would like to start with a short presentation.
Yes. You may start, sir.
Yeah.
So, hello, Amrit sir. Do you find
There is no
any
volume, please?
Yeah, I'm just trying to get this presentation screen shared. Just 1 second.
तो मैं उसको देती हूँ, मैंने उसको लिख के भी दिया है.
It is visible, sir. Now you may start.
Please start, Mr.
Right. So, so to start with just the flow of the session, so we would be starting with the background of the company, followed by background of the biomass industry, how we have arrived to the stage where we are today, and then moving on to the introduction to the different technologies of pellet production and the uses of biomass pellets. So high-tech agro happens to be one of the pioneers in the business in the biomass field in India. The first steps were taken in 1980, early 1980s, 1982 by my father, and I happen to be the second generation, as Dr. Dhamija mentioned. The first few machineries were imported from Switzerland. It was a dying technology all across Europe and North America, and kind of becoming obsolete. We got the machineries to India. We further developed the pre-processing equipments like dryers, hammer mills to suit the local conditions, based on the raw materials, because primarily across the world, when you talk about biomass pellets, it mainly 99% of it refers to only wood-based. And when we look at India, a country having different agro, producing a lot of different agri residues, so the primary machineries which were used itself were failed to perform because they were not really meant for the different biomass residues and were only meant for sawdust. So that is how we started, and by about 1985 we had streamlined the production of briquettes. We had developed our in-house dryer systems, hammer mill systems, and the briquetting machines were further upgraded to suit the Indian biomass residues what were available locally. From 1997 onwards, we started supplying these machineries across different parts of India, starting with Punjab, Rajasthan, Gujarat, then South India. And all these were customized because there were specific clients need. There were no standardized norms of the industry. So there were specific customer needs. Some people wanted smaller scale machineries. Some people wanted had larger residue generations themselves and were looking at larger capacity plants, more integrated solutions. So that is how we started the journey of providing the integrated turnkey solutions. And not only the individual entrepreneurs, we have also had of late we have also had FPOs, the farmer producer organization themselves, who have come up and who are wanting to actually utilize their own residues, be it cotton stalks, be it pine needles in Uttarakhand, be it bamboo plantations in the Northeast. And we have been providing solutions to all these sectors. So just a short look at the history. So in early 1980s, the first plants were set up. We started with we developed the flash dryers to suit the first materials, sawdust, which was used. And then we also developed portable briquetting plants because there was interest from a couple of agricultural universities in South, which were of the opinion that instead of getting the biomass to the fields, we would like to take the plant itself to the farms so that we can make the briquettes or pellets there itself, and then just transport the end fuel to to the consumer. So that was one of the very important developments that we had. Of late, with the, as Dr. Damija was mentioning, the air pollution, the importance of air pollution. So with the changing norms, there was a need which arose for having air pollution control equipments, which have now become an integral part of the systems, of the solutions. But till a couple of years back, this was in the briquetting and biomass industry in general. This was not something which was actually very relevant or present. So this was something that we introduced. Again, for pelletizing, apart from the normal pelletizing for fuel, pelletizing of a lot of materials is done for different food products also. So we introduced the temperature controlled pelletizing for food grade items. The biomass usage increased over the years, and there was a need of people started using biomass directly in their boilers, and very strong need came up for systems to remove the impurities from biomass, because biomass as it is, which comes from the fields, is something which will have impurities, which will have sand, which will have stones, and the boilers which are to run continuously around the clock were facing high downtimes, and this was something that we introduced to suit their requirements. Then RDF pelletizing was again something that we did. Paddy straw stubble burning was a major concern in Punjab, and the first couple of projects for paddy straw pelleting and briquetting in Punjab were done by us. 100% pine needle pelletizing. Pine needle again happens to be a major cause of forest fires in the hills, and this project was done with an FPO and the first of its kind all across the world, wherein we are actually pelletizing on the hills itself, 100% pine needles without any use of binders, and the fuel is actually sent downhill for consumption. So we've been into the business for more than 35 years now, supplied more than 500 plants worldwide, more than 100 dryers working, and perhaps one of the largest suppliers of the integrated solutions all across the biomass domain. Why we've been able to do all this is because we have a strong ecosystem, and we are supported by the premier research institutes. We've done projects and we've jointly developed systems with IISc Bangalore, ICAR Bhopal, Indian Agricultural Research Institute, TERI, Azadi, Acharya N.G. Ranga University in Andhra. So all these institutes, we have been continuously on a regular basis working with them for development, for identifying problems that we jointly foresee what could come up in the future and the requirements which would come up, and then arriving at developing the suitable solutions. So in terms of products, what we do is the conditioning of biomass. So any biomass, if we talk about, to process it into pellets, there is some amount of conditioning or pre-processing which is required. So chipping or size reduction, primary size reduction could be one of them. The second is the fine sizing, because to convert into pellets, you need the material to be in a small size, which is powdery or granular size that is required to be achieved. Then there are dryers for moisture reduction, because not all farm residues come in forms which can be directly utilized. Most of the materials have moisture levels which are way beyond what the pelleting or the hammer mills or the size reduction equipment can handle. So dryers are used for those. Impurity separator for the removal of sandstone metals from the biomass. So that is a very important equipment. Then the densification, there are briquetting machines, pelleting machines, material handling, all related equipment like pneumatic handling systems and belt and screw conveyors, bucket elevators. All these things are the entire range of product that we deal with, and what is required for setting up of a pellet production line. So coming to the background of the biomass industry in India. So the industry actually started in early 80s. What you see here is basically what you see in black is for the briquetting, and what you see in gray is for the pelletizing. So early 80s and till about 1990, the briquetting industry was in development stage. The pellet never really existed at that point of time. Small plants were set up. Brick kilns were the main users, small boilers, brick kilns were the main users of the briquettes that was produced. Moving on to the next decade, the briquetting industry pretty much started gaining momentum. Few larger capacity machines were introduced, hammer mills and dryers were introduced. And for the pellet, the industry had just started. This started with primarily municipal waste and very few biomass projects. The capacities were still in general small, not more than 20-30 tons per day. And so liquid fuel replacement had started, and so briquettes started moving pretty well. Pellet trials were done, but there was no concrete market linkage that could be established in this phase. As a result, the industry did not really pick up very well during that time. From the year 2000 to about 2016, the briquetting industry pretty much standardized. Many number of projects came up all across the country. Some of them were automated integrated plants working at about 100 tons, 150 tons per day capacities. Most of them being small manual setups which were set up. The range of agricultural waste which was utilized now increased. And apart from the directly usable materials like sawdust and groundnut shell, people started also going into other materials like cotton stalks, soybean husk, which were not as easy to process, but with the development of pre-processing technologies, these started taking place. Pellets also started, the pellets gained momentum, and a number of sawdust plants based on foreign technologies were set up. The primary market that the sawdust pellets addressed was the appliances like pellet burners, pellet stoves in small industry, which were directly replacing fossil fuels, liquid fossil fuel, and provided a significant cost saving. As a result, this really gained momentum. Also, the pharma and the FMCG companies, mostly all MNCs, started exploring the use of biomass, and gradually shifted by the end of this phase. Gradually started shifting to biomass as and where they found assured market linkages for the briquette and pellet supply. The biomass pellets industry still did not, apart from sawdust, the biomass industry did not really start, because there were few off-takers of pellets, and no real long-term linkages were found even till this stage. So post this, currently the stage in which we are in, briquetting is fairly streamlined. Integrated automated setups are coming up all across the country. Pre-processing in terms of cleaning, sizing, drying across all materials has been pretty much streamlined, and has become a routine affair now. The pharma, FMCG, mostly all MNCs still continue and are to use biomass briquettes and pellets. And in fact, whatever few companies which are not there till now on biomass are also trying to get themselves, as long as they can find the fuel linkages. Biomass pellet plants based on indigenous technologies which were developed now started getting established in this phase, and good number of plants came up. With the government policies and increasing awareness, and organizations like NTPCs and state-owned power plants, Reliance and Godrej, and many corporates all coming into the biomass sector have created a huge traction, and lot many number of plants are now coming up in the biomass sector as well, and sawdust appliances obviously continues. So probably a couple of years down the line, what we are looking at is a very established and standardized market with long-term offtake contracts, and also the contracts for back-end integration in order to source the raw material and work sustainably in the sector. So what all can be used for pellet production? So almost any biomass, any agri residue that you can think of can be used. Starting with right from sawdust and sanding dust to wood chips, shaving, all these being the woody biomasses. Moving on to the pine needles, juliflora, wild grasses, lantana, shrubs, bamboo chips, bagasse, sugarcane, trash, press mud, coir dust, all husks primarily, rice husk, coffee, sunflower, mustard, any husk of any agricultural commodity. Shells like groundnut, castor, almond, all stalks and straws like paddy straw, cotton stalks, mustard stalks, maize cobs. So these are all the materials that can be and are being used for the process of pellet production. So when we talk about the biomass pelletizing, the biomass, basically crop residues, leaving aside the wood waste, we are looking at primarily 3 types of waste. The first is the waste which comes from agri industries like groundnut shell, rice husk, bagasse. So these are materials which have been usage of which has been fairly well standardized and has been going on for quite a number of years now. The second is the material which comes from the farms but still is passing through some process like threshers and like soya, mustard, tur, dal. So these are the waste coming from these materials is something which is also being processed in the country as of now. The third and the most you can say in terms of quantum, the most widely unutilized waste and the major cause of the forest, the farm fires and the pollution arising due to it are materials like cotton stalk, cane trash, paddy, straw, which are basically left in the field, which did not have a great market till now and were not being utilized. So any production plant to be set up, the step before that is obviously the biomass collection. So just a brief on the biomass collection. So the first 2 categories are waste which are available in readily handleable form, which can be just loaded onto a trolley or a truck and can be got to the plant for processing. These straws and stalks, which kind of will be forming the major chunk of material that would be going into the pelletizing in the years to come, is the collection system for that needs to be established. So these are mostly collected through baling, and few materials like cotton stalks are done through online chipping in the farms. And in case of baling, we get the square bales, small square bales weighing about 15-20 kgs. And then there are, for larger farms and completely mechanized systems, there are round bales weighing about 600-700-800 kgs, which can be collected. So coming to the processing technology for production. So once we have the material, it could be bales or it could be chipped stalks, chipped cotton stalks, or any other chipped biomass. So we look at a primary sizing. So primary sizing is something which basically converts the material into a form from wherein it can be mechanized, it can be handled in a mechanized way. There is no need for any manual intervention subsequent to that. From here, if in case the moisture levels are high, it goes through a drying process. Then further to a fine sizing to convert it from say a 1 to 2 inch size to almost a less than 5 millimeter size, 5-6 millimeter size to ensure that it is in a pelletable form. This then further moves to the pelleting, and the pellets are made. So this is a typical layout for the a process flow for the biomass pellet production. You feed the biomass onto a moving conveyor. It goes to a shredder where the sizes are reduced to nearly less than 1 inch. From there, if the material is moist, it moves on to a drying process. The dried material then goes to the further size reduction into the hammer mills, and from here on into the pelleting line. The dust bag filters are installed for all relevant places wherever there is a chance of releasing the dust laden air. There is dust generation, and there is a chance of dust laden air going into the atmosphere. The bag filters are established. So a short video on the production process is now being played. So the separation of stones, sand, and any other metallic impurities, if they are part of the biomass, happens at the first stage. The crushed material then goes into the mixer, where if required, the addition of water happens and moisture uniformity is created, and it acts as a buffer. The dust laden air goes into the bag filter. The conditioned material from the mixer is fed to the pellet press. The pellets formed are quite hot at about 80-85 degrees centigrade and are cooled and dried and then sent for further storage.
Decentralized 30 kg, 50 kg, इसकी तो बहुत बड़ी हम लोग प्लान कर रहे हैं 25 जून को 25 को सब हैं सॉली चल रहा है.
So in case of the material going to smaller industries or appliances, the pellets could be packed in bags. In case of bulk consumers, like power plants, it needs to be sent in loose open condition, just open pellets loaded onto the truck. So the finished product pellets, just few pictures of different pellets from different materials. The diameter typically ranging between 6 to 25 millimeter, length 20 to 40 mm, moisture levels less than 14%, calorific values as per the raw material mostly in the range of about 3,500 to 4,000 kilocalories. Ash content, again, as per the raw materials, mostly what is preferred is less than 10% ash content. Density is ranging from 500 to 650 kg per meter cube, and fine generation of less than 5% is. So this is what a typical pellet specs would be, which is made from agri residue. So there are multiple ways how the processing could be done for the production. So the first stage, if you talk about primary sizing, so primary sizing selection of what kind of equipment would depend on the shape and size of the material, the moisture levels, the capacities that are desired, the material texture in terms of woody or fibrous, or what kind of texture does the material have. So multiple solutions. So twin shaft shredders are one of the solutions that is available for the primary sizing. More suited for larger capacity plants and materials with any kind of moisture level. Hammer mill type of systems which are suited more for smaller capacity and dry materials. Drum chippers which are more relevant for materials which are kind of woody biomasses with or without moisture levels. For drying, again, the shape, size, moisture, and capacities is what is important. So for larger capacity plants, 50 tons, 100 tons per day, normally rotary dryers is what is being used. For low moisture materials and relatively lower capacities, flash dryers are being used. And then sun drying happens to still be the cheapest form of drying for places like Gujarat, Rajasthan, Haryana, where there is ample sunlight available. So sun drying still happens to be one of the most cheapest and economical ways for smaller capacity plants. For fine sizing, we have different kinds of hammer mills, low speed, high speed, directly coupled, belt drives. So based on what kind of material type are we looking at, whether it is brittle or whether it is fibrous, and what kind of capacities are we looking at. So based on that, the different kind of fine sizing equipment are selected. Pelletizing wise, so in terms of capacity, end market, and material. So apart from the material properties, the end market also plays a very important role in deciding what kind of pellet press should be installed. So if you're looking at something like appliances and probably wanting to produce 6 pellets from the most woody kind of biomass, so then we are probably looking at a more specific ring die kind of a machine which is installed. If you're looking at any mix of agri residues and large capacity productions, then we are looking at horizontal flat die machines. And then there are mechanical briquette presses which are modified to suit the pellet making. And for small or medium capacity plants or for industries who are already having a setup of briquetting, or the mechanical press options happens to be a good option for them to start with to explore the pellet market. So few other items which play an important role in the production are the air pollution control equipments. These have become now most critical part because the plant setup, when you have multiple pre-processing stages, there is a lot of fine dust and a lot of fine biomass particles which are released into the atmosphere. And looking at the current industrial norms, it is not permissible to release those materials into the air directly. So air pollution control equipment have gained great importance now. Material handling equipment, because the plant capacities have increased, and now instead of just getting a readily processable material, mostly the plants what they get is material which has to be pre-processed by them, conditioned by them, to make it suitable to reach the stage of pellet making. And with the larger capacity plants, manual intervention or any sort of intervention in between the different processes turns out unviable and affects the quality and the consistency and the efficiencies of the plant. So integrated material handling equipments have become quite relevant now. And also, as the capacities have increased, more and more automated and integrated plants have started coming up. So electrical automation and integration also is one of the very important factors that is to be looked at. So with respect to the factors, so supposing someone decides to go into the biomass pellet production, so few factors that need to be considered before the selection of what kind of production technology they want to go into is the suitability with respect to biomass. So supposing if you're planning a plant on paddy straw as the primary fuel, your technology would be different as compared to probably what if you're looking at the solid bamboo waste. And the next would be the capital, the cost of capital as well as the operating cost. So lot many times what happens is if the capital cost is lower, but the operating cost is so high that it makes the project unviable. So these two things put together is something that should be really considered. And the availability of spares and service support. Biomass industry all across the globe has primarily been working on standardized materials like wood waste, primarily wood waste. These are materials which come in a specific shape, size, form, and condition, and you can have very large capacity plants with very manual, with very minimal involvement of manpower. But in the Indian context, when we look at it, we are in basically an agricultural country, and many agri residues are all different shape, form, sizes, textures, properties. So the local service support plays a very important role here to make the projects a success. So considering all the above factors, mostly what is seen is that the indigenously developed technologies turn out to be the most favorable because they are more suited to the biomass materials which are available here. The cost of capital as well as the OPEX cost turns out to be mostly lower than the other European machineries. And also the service and spare support is obviously more available. So in terms of from high-tech perspective, the advantages of setting up these kind of projects would be that we basically design projects which can run on multiple raw materials around the year. There is a assured productivity, product quality, cost efficiency. The plants are mechanized and automated, so there is limited manpower involvement and can be assured of higher efficiencies of production. So there is a systematic and comprehensive approach of actually the handing over the plants to the clients with proper training being given to the manpowers. And also a very important factor is the operation and maintenance of the plant. So biomass pellet production or any sort of biomass pellet or briquette production is something which till date, as Skill Council also mentioned, that new and more courses and structures are coming up now to actually standardize the industry so that we can have trained manpower. So as on date, the availability of those kind of manpowers is not there. So at our end, we are trying to see that we can have at least deployment of trained manpower from our side so that the production plants do not suffer on that account. So in terms of coming to the last section, the uses of pellets. So the broadly can be divided into commercial segment, which is the pellet stoves and pellet burners, premium quality of pellets, mostly wood pellets going into this segment. Then the industrial segment, which would consist of the boilers, thermic fluid heaters, hot air generators, all pharma, FMCGs, and textiles and all other different industries would fall in this category. And the latest which has now come up is the power plants, the government owned or IPPs, and they are turning out to be one of the largest consumers of pellets, basically far overtaking the first two sectors. So just to give you an example, say requirement of one plant, power plant would be probably, if you club together, maybe 20, 30 different industries, or maybe 200, 300 small commercial users, you would be reaching at that kind of quantity, what the power plants would require. And along with this, if you look at the pellet specs, so when you look at the commercial segment, you are looking at mainly wood waste, premium quality 6 mm pellets being sold in this segment. For the industrial segment, mostly agricultural residues, mixed waste are something which is being used. most common size being the 8 to 10 millimeter size, 8 to 10 millimeter dia pellets. And the general market acceptability would be for materials with less than 10% ash and about 3,800 odd kilocalorie minimum. So the market has totally changed with now the power plants coming into the picture. The market has completely changed because now these power plants are now open to using any and every kind of agri residue. The size limitations, which basically were normally for smaller boilers, 8 to 10 millimeter, now have gone up to 25 millimeter, and they are open to taking material with up to 25 mm diameter. And most importantly, even the low-grade fuels like paddy straw, cane trash can go into the system because they do not really have any restriction in terms of the calorific value. And the ash content as high as 20%, and 20% pretty much covers the entire range of biomass. So any biomass that would be produced would be at less than 20%. So it pretty much covers the entire spectrum of biomass which can be used. So with the power plants now creating a demand, the sector has is moving in a completely new direction altogether. So that's it from my side. I think if there are any questions, we can.
Thank you very much, Mr. Khater. I think Mr. Srinivas has a question. Yeah, Dr. Srinivas. Please. Can you please unmute him, Rohit?
Unmuted, ma'am.
Yeah, okay. Dr. Srinivas, please.
Thank you, madam. Once again, you have got a very good speaker. Many congratulations to you. And Mr. Khater, I think it was a wonderful presentation. I have been in the biomass sector for a very long time, and I'm very happy to see that you have been in business and improving upon it for several years and last 30 years. I have a question. You mentioned somewhere that finished product, some qualities. Is there any quality that either the client or the government, state or central, stipulates on the briquettes or the pellets? Briquettes, I think it is larger ones, what you are mentioning, right? And then pellets are essentially for stoves, etc. Right. So are there any quality parameters? Moisture content should be this much, CV should be this much, heavy metal should be this much. Varieties of things. You may be aware that there are standards for gasifiers. Only when they are 1000 kcal per normal meter cube, if it passes, correct, then gasifier is certified by MNRE. This was there some years back. So there are three areas which I see as quality parameters are important. First and foremost is the products. That's most important. Are there any standards or guidelines by the client or by the government, state or central or internationally, in your view? Second is at the plant and machinery. Are there any guidelines for, this should be the plant method? You showed very fines have to be made like this, and sand and stones have to be removed like this. I'm not too sure whether other briquette plant product manufacturers actually follow that. Are there any guidelines to that? And then to pick up the biomass at the farm level, there has to be, because ultimately that's the most important thing. If you pick it up with, biomass is hygroscopic. So if you pick it up with a lot of soil and etc., then there itself you have a problem. Are there any guidelines in that area? Whether in India or internationally, if you have come across, please enlighten us. I have asked a long question, but over to you to how to answer. But I also want to say that we are doing a biomass densification guidelines on behalf of ASCI, Administrative Staff College of India, for GIZ. And we would be happy to have a separate conversation with you to seek your advice. Thank you, and over to you.
Yeah, thank you, Dr. Srinivas. Would be a pleasure to get associated. Coming to your question, in terms of guidelines for pellets, so there are two ways you can look at pellets. You can look at the physical properties and the chemical side of it. So when you look at the physical properties, yes, there are guidelines which the or which all the power plants have come up with now. So in terms of sizing, like the diameter of pellets, not more than 25 mm, the length not more than 40 mm, the moisture not more than 14%, the generation of fines should not be more than 5%. And they have developed standardized processes for how those items are to be tested. So that part, yes, there are some amount of guidelines. If you talk about heavy metals or presence of alkalis and all those things, so no, at present, there are no guidelines on that. The primary reason I would say is that because the quantum of co-firing as of now is so small that we are not looking at practically, even though the requirements have now started coming up for 5% co-firing, 10% co-firing, but in actual practice, we are not looking at even 1% reaching about 1% right now. So maybe down the line, definitely yes, even the chemical properties would start coming up, and that is one of the primary reasons I would say that you would also be looking at maybe transitioning to more processed fuels, like maybe torrefied biomass and all those things. But yeah, right now the market, till the time we are not reaching that 5%, 10% kind of figures, which still seem to be far away based on the current production capacities in India. There are only physical guidelines. If one is able to meet those, they are good enough to be consumed in the power plants. The second part with respect to the manufacturing, the method of manufacturing. So no, there are no guidelines as such. So there could be good practices in terms of what should be done. But yeah, there are no guidelines as such, because end of the day, any consumer of the fuel is concerned with the end product that he gets. If the material is not produced in a proper way, it would not be having the proper densities or proper, the contamination level might be high. So the product will not fetch the suitable price in the market. So as of now, there are no guidelines, but yes, we are doing our bit to basically share the knowledge on that front, how the production can be made, how you could produce better quality products at nearly the same or lesser cost using better manufacturing practices in the industry. So efforts are being done on that front, but there are no standard guidelines per se.
Yeah, if I may intervene, I think Mr. Khater, we did constitute a committee of BIS. There was a committee of BIS on standards for pellets.
Right.
Now, how far that committee has, has gone in getting these standards? Because during a visit to Nagpur for the pellet industry, this was the issue what Mr. Srinivas has raised regarding standardization. And the pellet manufacturers were also saying that we have got limits set by the state labs, not for a centralized agency. So I think BIS, you can, Mr. Srinivas, there was one Mr. Chandan Banerjee there. If you can, I can give you his number. We can still get in touch with him and see if the standards have been, they have come to a conclusion that these are the standards. But I think NTPC and all, as Mr. Khater said, this was a question when there was a vendors meet for the NTPC by NTPC. There also the question of standards had come. How do we finalize what we want?
Yeah, thank you very much, madam. I will definitely get in touch with you and Amrit also. In fact, in this meeting, former executive director at NTPC is also there, Mr. Rajesh. We have him as a resource person with this thing, but I'm not going to take more time asking more questions now. I know there are many other hands which have raised up. I will have a separate discussion. Thank you for this opportunity, Amrit. Excellent presentation. Thank you very much. Over to you.
So we have one Mr. Ashish Vaishnav. I think Mr. Rohit, could you unmute him?
Yeah, good afternoon and thank you very much. Are you able to hear me?
Yes, good afternoon, very clearly.
Yeah, thank you, Amrit. Wonderful to know. I have been from the application side of biomass, and one of the things which you very rightly pointed out is the maturity of the industry. India took up briquettes as the way forward rather than pellets, and So as a end user, customer is always wondering what to go for your boilers and heaters. Is briquette a better option or pellet a better option? And the way the pricing structure has been done for the pellets, like you explained for various applications, sometimes it seems prohibitively too high for the same material. So you being a manufacturer of both equipments, the raw material remains the same, but how is the end cost of a briquette versus a pellet, where the CVs will remain the same because the raw material remains the same? And how would that help end user to make a decision?
Right. So, Mr. Ashish, the thing is that the pricing structure is controlled by the demand and supply, and not really by the cost of production, the direct cost of production. So that is something which eventually, maybe a couple of years down the line, will stabilize, because currently the market situation is that the pellet requirement in the last couple of years has absolutely boomed. And we were looking at a production of hardly a few dozen plants in India, and all of a sudden, say, power plants came up with requirements of, say, a few million tons or massive numbers. So along with this, also there were industries like other process houses which started using pellets. So because of the sudden demand and the very low level of productions as on date, the pricing difference between the briquettes and pellets is much higher. If you look at the actual cost to cost difference in terms of production, you are hardly looking at maybe a 600 rupees, 700 rupees at max kind of a difference. And that, coupled with the efficiency increase in terms of when you handle the material at your end as a user, the automated firing, the improved surface area of the pellets, uniform sizing, uniform density as compared to briquettes. So any large consumer would, if they are using a briquettes, they would normally be crushing briquettes and using it. So when you compare the crushed briquettes to pellets, even though the material might have the same calorific values, you are looking at a much higher, much lower consumption in terms of pellets, due to the fact that this remains densified in the same form, very uniformly sized. So if you just take the cost difference part, which is the actual delta, you would be looking at pellets as the significantly favorable fuel. But yeah, in the current market, you are very correct, with that being controlled by the demand and supply, and the supply being so limited that there is a significantly high cost of pellets. But that, I feel, would be that is basically a temporary situation. That is not a permanent situation, because more and more with the requirement now, more and more plants are coming up, and eventually a couple of years down the line, these things will stabilize. So the pellets and briquettes would not be far away in terms of pricing like what they are currently.
Okay, thank you very much. But from a cost of equipment, sorry, I'm taking a half a minute more. From a cost of equipment of setting up, say, a 10-ton or a 20-ton per day plant, between a briquetting and a pelleting option, how would that change in your view currently?
So the capital cost for pellets would definitely be higher. If you look at smaller capacities like 10 tons, 20 tons kind of capacities and directly usable materials. So if you talk about a groundnut shell-based briquette plant versus of 20 ton per day versus a groundnut shell-based pellet plant, the cost you would be looking at maybe double the cost. But the industry is quite fast, in a fast pace, shifting towards larger capacities, more integrated and automated plants, and most importantly, the materials which are not directly utilizable, because materials like groundnut and sawdust are the quantities are limited. So you're looking at materials like cotton stalks, cane trash, paddy straw, and when you talk about these kind of materials which whether you make briquettes or pellets, it requires significant amount of pre-processing. So for those kind of materials, the capital cost of machinery also is not greatly different. It would be higher maybe by about 20-30%, but it's not like you would be spending double the investment on this. And then you have savings in terms of the manpower. So limited number of manpowers can be deployed to run a pellet facility, whereas briquetting cannot be completely mechanized. Briquetting plants cannot be completely mechanized in terms of briquette handling. So when you look at anything above 50 tons capacity and materials like farm residues like cotton or cane trash and paddy, the capital cost also is not greatly different, and the operating cost is also not greatly different.
Thank you very much.
Yeah, I think we have. Yeah, Rohit. We have Dr. S.K. Tyagi from IIT Delhi.
Unmuted, ma'am.
Yeah, please unmute him. Dr. Tyagi, please.
Ma'am, he's unmuted, ma'am.
Good afternoon, everyone. Hello, ma'am. And Amrit, how are you?
Good afternoon. Good afternoon.
Yeah, Amrit, I have just a small query. In fact, to educate myself. Is there possibility to get 5 to 10 kilogram per hour capacity this pelleting machine, which can
Can't
use for different?
we can't hear him.
Biomass?
Can we hear him, Rohit?
Hello.
Yes, ma'am.
Can we hear Mr. Tyagi?
No, ma'am. The voice is not so audible.
Yeah, please, Mr.
Hello?
Tyagi, slightly louder.
Hello.
Yeah, hello.
Hello, ma'am.
Yes, sir. Now it is audible.
Yeah.
Yeah, I think
Yeah,
I
good
got
afternoon
his
to all of you.
question.
Good afternoon, everyone.
Yeah, very good afternoon, Dr. Tyagi.
Yeah, Amrit, I just have one query to
Yes.
educate myself. Is there something which can be used to make 5 to 10 kg pellet per hour using different type of biomasses? And what could be the tentative cost if it is not, I mean, comfortable for you? Then I can call you sometime later. But I just want to know if it is available with you.
Yes, so smallest capacity as a lab scale, you can call it, would be about 50 kgs an hour. 10 to 15 kgs an hour would be too small a quantity, and it might work on very few materials, which are very easily pelletable. But for most of the other materials, we will not be able to generate that kind of force which is required to actually do the pelletizing. So 50 kgs an hour is what is the smallest capacity of machine that is being there right now, which is used as you can say a lab scale model.
And how much area it will require to install, because we have space crunch in IIT. So
no, space is not, so the machine footprint is hardly 1.5 feet by 1.5 feet by about 4 feet. That is the only footprint. So the footprint for the machine is not high, but yeah, when you're looking at biomass, then obviously the area for the biomass would be required. So even if you're doing say 300-400 kgs of material, so to store the biomass, you will need some area. The machinery footprint is very, very small.
Okay. And tentative cost, any idea?
Yeah, tentatively, this kind of a machine would be costing not more than about 3 lakhs.
Okay. Thank you. Thank you, ma'am. It is a nice discussion today. I have listened something.
I think we have Mr. Deepak Rai. One question. He's raised his hand. Mr. Deepak Rai.
Thank you, madam. Thank you, Mr. Khater, for this wonderful presentation. I just have a quick question. It's mainly about this biomass co-firing mandate that came up from I think last year. You mentioned the industry is not able to reach even 1%, if I understand correctly, compared to the 5 to 10% kind of the mandate which is coming up. I do understand it all started with the Dadri NTPC unit, and a lot of successful example later on came in. But you know, we have been hearing all this hue and cry regarding the coal shortages, and the railways starting off these, and the passenger trains being stopped, the express trains being stopped just for passing, making sure that the plants get the coal. And every now and then we do hear about all these changes. So what opportunities does the coal shortages in the existing thermal power units presents for this industry in India? 5 to 10% mandate, is it small? Is it, why the sector is not able to reach out to this? Is it only the supply part of it, or the cost dynamics? And potentially the last one, maybe would there be opportunity for exports as well in future?
Right. So So the thing would be that if you talk about the impact of coal shortages on the industry, so coal shortage is something which is basically has created an increased demand of the biomass fuel, pellets, briquettes, raw biomass, all the things. So, but for actual development of the industry, it is at the you can say a policy level, because coal shortage is something, or coal price increase is something which is there today, but not everyone is sure about how long the price rise might be there. If it is selling at say 10 rupees today, tomorrow it could be 12, it could be 8, it could be 6. So based on that, the industry does not really new investments, large scale investments do not really come just based on that one decision कि आज coal की shortage है तो आज plant लगा लें. उसका जो impact है, the coal shortage impact is there, that whatever plants were there earlier, which were probably running at 50% capacity or 30% capacity, are now running at 100% capacity, or maybe have expanded and are running at 200% capacity. So that is the impact of coal shortage, because the whatever could be done in a short span of time has been done based on the coal, the sudden demand of biofuel which came up due to the coal shortage. Then if you look at the exports, so that is one of the places where we have actually been discussing quite a lot. And what I personally feel is that export of pellets is something which, based on the Indian context, is not really something which will really create great avenues, because the Indian market itself is so huge. And with the 5 to 10% co-firing norm coming into play, and more industries shifting to biofuels, and with the kind of mandates that 5 years down the line we have to be at say 50% or 100% biofuel consumption. So the captive consumption itself is so high, and the price is also reasonably lucrative to actually sell the fuel in India itself. One of the primary challenges with exports is that you need very standardized quality of pellet. So there are like norms for the pellet, grading of pellet, which is done for the European market or the Japanese market. And when you look at pellets being made in India, so it is not like we cut wood and then we basically, it is not deforestation that we are doing. We are cutting wood and then again we are processing it and making pellets. So the kind of quality consistency that is required for the export markets is also not there. The kind of volumes that we require for the export markets, container load shipments do not really turn out that viable. If you look at bulk shipments at 20,000, 30,000, 50,000 tons in a single shipment, those kind of quantities are not there. Probably hardly a couple of plants in India which might be reaching those numbers on an annual basis. So obviously you cannot be looking at bulk shipments. So there is no real advantage that we see in the current context of pellet export. The Indian market itself offers the same or a better price. They are more open to accepting agri residues as compared to wood, because the industry is stabilized, and India happens to be one of the leaders in the biomass processing. If you actually look at it in terms of biomass processing, be it briquettes or pellets, India happens to be the leader. And so does the similarly the consumption point also. So if boilers using these high ash materials and materials with low melting alkali salts and all those things, so even from the consumption point of view, India is one of the leaders. Even from the processing point of view, we are one of the leaders. So sending this material to a market which is not really open to taking up higher ash materials, and which does not actually take up prefer to take the materials in smaller shipments. So export does not really look like a very favorable option as of now.
Okay. Thank you, Mr. Khater. There is one more question in the chat box. I think this is from Mr. P. Rajesh. He has asked about the safety standards being followed in machines. I think this you have already answered when Dr. Srinivas asked. And what is the second part is, are you specifying the specific energy consumption of the machines being sold?
Yes, so any project that we do, so based on the input parameters, so there is a matrix that is made that what would be the processing equipments involved and what would be the power consumption for the process. So, and then there is a capping. So how it works is basically any project that anyone is setting, we understand that the operating cost numbers are basically very, very critical. So and power happens to be one of the most almost like 40% of the input cost, 40 to 50% of the input cost. So there are definitely, yes, there are numbers which are freezed for each and every material, that this would be the maximum energy consumption in case of this material.
Okay, thank you. I have only one question, a small question, because I think a lot of questions have been asked. I had seen some small, pellet making machines across Nagpur, that cotton belt,
Yes.
where cotton stalks, where, the residue of cotton stalks was being used. And these were very small, 30 to 50 kg per hour capacity. So yours is a huge system which you will be generating more. How do you see the DRE, or we wanted to take up pellet making machines which we could set up in villages so that it could create livelihoods, but then the problem comes of the market. So how do you visualize, the large infrastructure requiring machines or the small one which can use, there will be no problems of storage, there will not be much problems of transportation also, because transporting biomass again is a costly matter. So how do you see this vis-a-vis the DRE or the small machines which I have been seeing in the Nagpur belt and all over?
Right. So for that, so it is not about either this or that. The way we look at it is that there is a space for all the all capacities of machines that could work. So if a self-help group or a women entrepreneur or a small entrepreneur in the village wants to set up a small 50 kg per hour machine, maybe producing 400 kgs a day, so that is absolutely feasible, provided they come under an umbrella which provides them the end market linkage and gives them sufficient margins and provides them the end market linkage. If you look at commercial plants as a business activity, if someone is to do it, say if I am to set up a plant and at 20 places across India, so then obviously it cannot be small capacity. It will have to be a minimum viable capacity for the business activity to run. And when even saying that large capacity, but even 100 ton per day plant, when we set up for places having a double cropping cycle, we are hardly covering 2-3 kilometer radius from the plant, 4 kilometer radius from the plant, not beyond that. So the material availability is not a challenge. The decision of small or big is to be taken based on what kind of entrepreneur is setting up. So we have small capacity plants being set up in the foothills by on the hills by FPOs, or running on pine needles. So there obviously a larger capacity system would not be viable because sourcing the material and all those things will be a challenge. And then they have an end market linkage, producing premium grade pellet, selling at 15-17 rupees a kg. So it becomes a good business activity. Okay. But yeah,
based on the availability of feedstock, based on the marketing linkages, I think we can decide on the size of the plant. Yeah.
Right.
So I think I should thank you, and we can end it here. And there are a lot of thanks in the chat box also. The presentation was very good, and we are very thankful to you for sparing so much time and giving us so much information from where I left, so many vendors. I think now the number of vendors has increased, and of course, the output or the pellets, the quantity of pellets that you remember when we in MNRE we met, we people had to see where is the market, how to channelize it. So all these challenges are being met step by step, and with the commercialization of this industry and the marketing linkages for the big power plants, I think this is really going forward in a very good way. Thank you once again. And
thank you.
I think now we can.
Thank you. Thank you.
Have a good day. Yeah, please. Thank you very much. I think just, yeah. So all of them have appreciated your presentation, and thank you once again.
Thank you so much, sir. Thank you so much, ma'am.
Thank you.